Hey, this is the sixth episode of Automat DEVLOG. Today we are going to take a look at our assembly environment. We managed to get some of the cards populated. Maybe not some, actually all of them. Here we can see the assembly instruction, JRCX0, and its description that we will use in Automat. This instruction, if you look at it, JRCX0, it's you kind of need to know what it means. You need to know that this RCX, this is the register name, J means jump and 0 means 0. And this 0 here, it's actually an address where we will jump. So this is the equivalent description that we are producing. And if we grab this card, you can see how it works. It has two connections. There is the jump connection, which allows us to connect it to a different instruction or a different object. And there is the standard next connection, which will just activate if the jump is not taken. It's easy to create loops, like that, or just by hooking this to any other instruction. And we have plenty of instructions like this one. So this is an instruction which decrements the CX register, CX represented as a circus, and then jumps. And yeah, we have just a bunch of instructions that do a lot of stuff. We have tons of control instructions. We can generate random numbers, get current time. There are instructions for all of those things. Do math, move values, conditional moves, swap values, all sorts of operations. We don't cover 100% of x86 assembly, but that's our ambition, to eventually cover 100%. We don't want to confuse users with too many instructions, so a lot of them will be set aside in booster packs that can be enabled if you want to activate them. So I would like to show you a couple of ways that Automat is going to use assembly instructions to control the flow of execution. So there are three different ways to create a loop here. The first one uses the CX register. We are setting this to 10. This is the instruction move CL10, but in a slightly more understandable way, which then executes some Automat object, right? It can be any object, it can be some macro or whatever. And after it executes, the next instruction, you can see it's connected, but the connection is hidden when they touch each other, is going to be the loop instruction. The loop instruction is actually a very interesting because it's a single instruction that can allow us to do loops, essentially. So it will decrement the CX register, so from 10 it's going to go to 9, 8 until 0, and when it reaches 0, we will exit through this cable. Otherwise, we will loop around. So this is a small program, a mixed Automat and assembly program, which is going to count 10 seconds. All of the programs actually do the same thing, they just do it in a slightly different way, using slightly different instructions. This one uses a different register. This one uses a DX or a DL register. So first, it sets the low 8 bits to 10, so it sets the value of this register to 10 essentially. Then we are executing some Automat code, and then we are jumping back to assembly where we are decrementing this register, and if it's greater than equal to 0, this is actually implicit, the 0 is implicit in all assembly instructions. Maybe we'll have to change how we show this condition. Then we jump around. So this is another loop which uses this connection to loop around instead of the next connection. And lastly, we have another way to loop where we count from 0 up. It's slightly longer because we first set the register to 0, then we execute the code that we want to execute, and then we, instead of decrementing, we increment and we compare the register with a fixed value, here with 10. And you can see something here, the AL register, which we represent as an axolotl, is shown in blue. When a register is shown in blue, that means that this instruction actually has to use this register. Some x86 instructions are just like that, but there are usually variants that would allow us to pick different ones. So here are end instructions, and you can see that some of them are fixed. They require a AX, but some of them allow us to pick arbitrary register. They are usually slightly longer. Then we have a condition which will jump if we are less than 10. So those are 3 different loops, and this kind of shows you that assembly is a very flexible language. There are often multiple ways of achieving your goal, and the simple cards that you get, they allow you to do very simple steps, but you can combine them in whatever ways you want to achieve what you want to get. None of this is working yet. To get this to work is actually the plan for this week. So this week we're implementing the actual code emitter. Okay, so that's it for today. See you next week. Bye.